So the only order it can be is either 2 or 4. Now this was all when they're all of order 2, and here we're going to analyse when at least one of them has order 4. Okay, so let that element, whatever it is, let it be A, right? And A is of order 4. So A to the 4th is E, right? Okay, now if it has order 4, you can generate a subgroup of the group using A. So E, A squared, A cubed. We did a theorem quite a while back that that's a subgroup. We actually proved that that's a subgroup of G. Okay, so these 4 elements, since they're a subgroup, they're distinct from each other, right? And they are a subgroup of G. Okay, now so we've got 4 elements now already. Now we don't know what it is, but let B, whatever, let B be the 5th element. We argued like this for G6 previously. So a lot of this is like a carryover from G6. It should be familiar. All right. So let B be your 5th element. So it's distinct. It's different from these 4. Okay. So B, it's distinct. It's not one of these 4. You're assuming that. All right. Now because it's a group, groups are closed. So if you bring in this 5th element B, B, BA, BA squared, BA cubed, they all have to belong to the group as well, because you in your group table you will have a BA and a BA squared and a BA cubed from the entries in the group table, right? So and they're all distinct from each other. If they're not, well, you could prove that. If you say they're not distinct, well then you get contradictions. So these 8 here are the members of your group, given this B, which is different from these. All right. So there's your group. Okay, and you'll have eight distinct elements. Now let's now start trying to fill in the values of the group table. We're trying to construct the group. If you know the group table, you know the group. Right? I've said that many times. If you have a full knowledge of the group table, you know everything there is to know about its group. The group table is the group. Okay, so let's try to find the value of B squared. So here's your group table. Here's B squared. It's actually, for example, that element, this element here, B squared. What is it in this context? Well, B squared cannot be any one of these 4, because if that's not the case, you get contradictions. So let's quickly show that that's true. B squared cannot be that one, or that one, or that one, or that one. Well, this is why I say else, meaning that, well, if that weren't true, then, okay, so if not true, then, or else. Well, that would mean, so if B squared's B, that means B is E, right? But that's a contradiction, because B is a 5th element. It's distinct from these 4. Okay, so B squared is B is out. Now if B squared's BA, that means B is A. Well, again, B's then not a 5th element, it's this one. So if B squared's BA squared, then B equals A squared. Again, it's not a distinct element, it's this one. And if B squared's BA cubed, then B is A cubed, so it's this one. Again, same argument, not distinct. It's B is the 5th element. So B squared cannot be any of these 4 values. All right. So cross. Now B squared can. So we've eliminated these 4 as the value of B squared. So we have 4 remaining that we can check. So is B squared equal to A? So now is it equal to A? Well, assume it is equal to A, then now the order of A is 4, right? That's we assumed that here. We assumed A is of order 4. So therefore A to the 4th is equal to B to the 8th. Right? Now this 4 here, that's the first time, that's the first power as you go up, like A squared, A cubed, A to the 4th. That's the first integer you get going up in power, where A to some power is E. That's its order. So this correspondingly B to some power, that's the first time that it becomes equal to E. So B to the 8th equals E. So that means B has order 8. But we eliminated that here. So from here onwards, we've been assuming there is no element of order 8, because that was the case when we were talking here. But here, there's no element of order 8. Right? So that's a contradiction. So therefore, B squared cannot equal A. So we've eliminated another one, got rid of that one. Similarly, B squared cannot be equal to A cubed, a similar kind of reasoning. Right? So you assume the opposite. Assume B squared does equal A cubed. Well, then you'll get a contradiction. So there's an argument by contradiction. So assume B squared does equal A cubed. Well, take the 4th power. So what's the order of A cubed as an element? It's one of the elements here. No, here. Right? It's one of the elements distinct from the others. So what is its order? Well, you have to get up to A to the 12th. Does that make sense? Yeah, you have to. That's the first time when this goes to E. A to the 12th is E, because A to the 4th cubed is E. And so correspondingly, what power of B do you get to going up, up, up for the first time to get E? Well, it's 8. So that means the order of B is 8 again. It's the same argument as this one. All right? So B squared cannot be A cubed. That's left out. All right, so that leaves us, so we've eliminated 6 of these, and we have 2 cases left. So B squared is either this one or A squared. So we eliminated that one and that one. That's these 2 cases. So eliminated that and that. And we eliminated all those here. So we're only left with B squared is E, or B squared is A squared. So we have now only 2 cases left. Right? The other 6 we eliminated. All right. So let's now do case 1, where B squared is E. All right. Well, now let's try to find what AB is in the group table. And we did something similar for G6. So what is AB? Now a similar argument. AB cannot be E, can't be A squared, can't be A cubed, and it can't be B. Why is that? Well, assume the opposite. We did this for G6, so this will be familiar, so I'll go through this quickly. Okay? Let's say AB is equal to E. Well, that means that A equals B inverse. A equals B inverse. But B squared is E, so the inverse of B is just B. So if A equals the inverse of B, that means A equals B. Contradiction. B is a 5th element. It's different from A. So that doesn't work. So AB cannot be E. How about AB is A? Well, that means B is E. But it's the 5th element, so that's out. So how about AB equals A squared? Well, that means B equals A, 5th element. Doesn't work. Right? How about AB equals A cubed? Well, that means that B is A squared. Again, B is the 5th element. It's not one of these. And how about AB equals B? Well, that means that A equals E. But no, they're distinct elements. So you get all these contradictions. Right? So AB cannot be any of these 5. Right? So what does that leave? So what's still left over? BA squared's a possibility. And what else? BA's a possibility. Sorry. Well, anyway, so we've eliminated 5. Now let's eliminate a sixth. So we'll get another contradiction. So we'll show now that AB is not equal to BA squared. So we're going to knock out this one here. So proof by contradiction. Assume the opposite and get a contradiction. Go back and negate your negation. Right. All right. So assume this is true. So AB equals BA squared. Now if that's true, then take B inverse on the right hand side both sides. So the B's cancel and you'll get BA squared B inverse. That's here. Okay? Now if that's true, A squared, so you square all this, so you've done it there. And look, this B inverse B, that cancels, so you're left inside with A to the 4th. Okay? But A to the 4th, the order of A is 4. Okay, so A to the 4th is just E, so you get E here, and B inverse is just E.